okay, nice energy. You know, it was a little gloomy out there. I was worried y'all weren't going to have that spunk to it. A nice quick in, and I like it. Well, in that case, we'll go ahead and jump right in. As a reminder, your problem set is going to be due right before Turkey Day, so make sure you take care of that as well. But we're sort of carrying on with our topic of what we're kind of going into what we call classifiers, right? Where we've introduced machine learning and we're, again, trying to make an assessment about whether something is something. And that becomes a very challenging problem, especially as we start dealing with what we called unstructured data. Ooh. Unstructured data, right? This becomes a much harder problem than just, oh, I can throw it into a program. This is literally where modern era research is. It's trying to tackle things like text. I want you to think about how you text with your friends or your group chatting with your friends. Do you use proper English? No. I read your problem set 5s. Some of y'all are going to get some grammar deductions. Like, I know we're not an English class, but my God, step it up. My point being, right, this is because, like, it's much harder to process your text, especially when you're in a text message. And so what I at least open up to start with is let's look at the following text messages. So, first one, wait, that's still not all that clear. Were you not sure about me being sarcastic, or that's why Bill doesn't want to live with us, ... Or, congrats, 1 year special cinema pass for 2 is yours. Call that number now. V, Matrix 3, Star Wars 3, free. Which one of those are spam? The one on the right. We all, again, I will open it with like this. Why is that one spam? I mean, my mom tells me to call my grandpa on his birthday, so is that spam? You never made plans making a text, to go see a movie? There is the third Matrix. Yeah, I know, but... And Star Wars 3 did happen. Yeah, but they call it Episode 3. Nerd. Okay, so some weird stuff there. I'll at least contest against the 3 part there. Like, technically, it's a third iteration, Yes, I get where you're coming from there. But that calling of the number, again, that's also still like humanistic behavior. If I give you a number and I'm like telling you to call something, so the rules get a little harder. Again, I've seen y'all's writing. So spacing isn't really a problem either. I don't see anything. Why that? See, I'm trying to dig a little. They aren't selling me anything, but you said it's super obvious. Why is it super obvious? Like, what is it? What is this? They're getting my. Well, I mean, that's a notification. I heard something over here, a rumbling. I'll say authentic, not authentic. And there's a lot of this. Again, so you're all right and also slightly wrong at the same time. This is, again, welcome to spam detection. So a lot of what we start to kind of look at this is things like a call to action. And again, call to actions are still something we do as a human, like that's go sign a petition, go buy my book, things like that. But specifically, if we're looking at that, doing this action now, oftentimes if you look at a lot of our crypto scams or our financial scams, what we see with those is those types of messages you have 2 days to respond or we're going to lock your account. We know it's a scam, we know it's spamming because of that call to action. Again, nobody really tells you that except for bills. But yeah, again, you understood it. You all got it. There was something in the nuance between these two messages where you could look at, again, Alan on the left and say, okay, that's a legitimate text, most likely. Where Alan on the right, most likely spam. And in fact, you are correct. I'm not dismissing that at all, but I am challenging you on what you consider to be spam criteria. Because again, this is a hard problem. This is, again, what we are sort of looking at. And so, at least to start, what I'm going to at least kind of propose, and this comes from last year, so it's a little dated, but it was, I think, Yushin wrote this before the era of ChatGPT, as how I'll kind of present it, but that doesn't mean like it's obsolete. So again, if we're thinking about it, Reddit, social network, lot of content creation. How do you detect when you're dealing with spam, hate speech, misinformation? How do you even do that? How do you try and tackle that at scale? Because it's very difficult. And we'll dig into this a little bit more, but you notice specifically that whole chain gets into, it's a pattern. There's a behavioral pattern that happens, and that's how we detect spam. So again, if we're looking at this from the lens of a unstructured data set that we use machine learning to tackle, that's again where we're sort of tackling this. Well, again, we may not have all of those different attributes. I may only just have one large attribute called message, and it's just the message that again, I receive. And again, there's a link to where these things are. So that's it. That's your data set. It's from 15 years ago now, so it's very old. But that's it. That's all you're getting is message, whether or not we labeled it, whether the research team had labeled that as ham, not spam, or spam. Okay, well, again, in that case, how do I tackle this problem? Like, how do I design out a model that can take my unstructured data, process it in such a way that now I can apply math, right? Again, we're secretly just math in the background. How can I take a sentence and transform it into a math problem? Again, that same process can come in here. Again, if you looked at those new messages, can I take this, do something to the words that convert this into a math problem? Because if I can, congratulations, I can now make some kind of assessment. Just like we saw with decision trees, right? This is the same kind of slide with the decision tree. The only difference is instead of it being 4 criterias, we're now looking at just block of text. And again, you can all see which one of these is ham and which one of these is spam, right? I hope. So again, let's look at those messages, and here's why it was problematic. Yes, we talked about it, right? I started saying, oh, the words like free aren't really good, right? I've seen your college students, and we know that college students, I think it's like 10% of you have food insecurity. To make this a joke, to take a serious matter and turn it into a joke, notice how we'll often send out messages that, hey, there's free food in a location, right? Or we offer free food to events. Right? It's to get you, let's get you go to the event. So free doesn't necessarily mean that you can get away with it. Congrats. Same thing. Again, you pass your exam. If you don't have a react button on your application, how did you say, good job? You said congrats. You said good job. You had these things before emojis existed, right? And so again, that doesn't sort of work as well. But here are some other types of issues, just more general, right? Instead of it just looking at the spam, let's look at it from both perspectives. And remember that it's no longer that we're playing English, we're playing string, right? Think about that. Again, when I look at string comparisons, Bill does not equal Bill does not equal Bills does not equal Bills. I said the same word, and those all, again, look at it, the spelling's the same, except for some of them are plural, some of them are not plural, they're possessive, some of them are a noun, or a person, and some of these are the thing. And so from a string, again, like from English, we understand that they're the same, they're not the same, except for sometimes they're the same, and sometimes they're the same. From string perspective, though, remember, what happens if instead of doing it just arbitrarily like that, I went into Java and I had done that? Bill equals Bill, true or false? False, right? So again, we've looked at this from a binary perspective. So all of a sudden you can see punctuation becomes rather problematic, because if we're dealing with this, you also learned this whole thing, right? Separated, transform a string into a list or an array by splitting on your spaces. The problem is, again, that's not really spaced out, and that becomes problematic. So those ... us is not going to be the same as ... clear with a comma, not the same as clear without the comma. Inflections of words. Again, this is sort of repeating what I've got going on here, but you can see that because of that, both of them are going to have this. Or, again, that same thing, improper grammar or informal communication also still has this major issue where I don't follow grammatical rules. And so it's, we can't say that just not following grammatical rules makes it a spam messages. And then again, the clear thing of free versus not, free versus free or bill versus bill changes as we look through these, right? So this is all the problems that from just trying to turn this string into a number, into a math problem, already becomes a complicated mess. And again, that's our focus today, is trying to process this natural language in some way. So here's where I'll start to at least give you some terminology. We have something in NLP we call stop words. Stop words, just like it says on there, they're frequent. It's these kinds of words, articles, just something that's all over the place. It's so frequent that I can't use these words in any sort of beneficial kind of way to decide, right? Again, I think you said the free. That's why I keep looking at you, right? Free, okay, maybe that has some significance, but again, we're trying to treat this like it's a math problem. And some of those variables that I have in my world right now are way too common. So that issue of them being too common makes them insignificant. We no longer need to worry about these things because, again, pretty bad. So how do we tackle even just that stop word problem? The first thing we do is, yes, we still do the split. You still go into that string, you convert it into a split of those words into, an array of them. You'll see this term oftentimes used. BOW. Bag of words. Again, what's that doing? It's just we take the text, and now we have a collection of the words the tokens, I'll start to kind of refer to them as, we have a collection of tokens that made up that message. And this is where, again, I start to kind of present this as, it's not that matrix 3, or those 3 on them are bad, it's just that's a token into the whole sort of equation. It would be different if it was matrix space 3, but again, it's just how we start to break things down. So again, nothing outlandish here. You see what's going on, right? Makes sense. It's not blowing your mind too much, right? Good. I taught you how to do dot split and you're done and you can walk out of this class. But notice again, when we do these splits, this is where it can be a little more complex than just the dot split. And now, yes, there are ways to do this. We'll talk about them. But rather than just doing the dot split, we start to separate out the words, maybe in a more intelligent manner. Because, right, doesn't is just, now I'm showing my English skills. What's the word for this? This is a contraction, right? And it's more to the point of it's 2 words, right? Does not. Oh, well, again, those are these. That's still a contraction? Okay, thank you. Ugh. Y'all have taken English classes much sooner than I have if we look at like the history. More recently, right? I am. And so maybe our splitting, when we separate these into tokens, is not just the dot split method, but we do start to account for these. If I do see contractions, right? Oh, split them, but not just do a dot split, right? Do it properly kind of things. If you see the in T split, that's a not going on there. So again, all right, that's going to tackle some of those problems. It's now sort of separating possession a little bit. Then what? Then we get to something known as root words. That same kind of approach comes into play. I want to take this term. I'm going to just work off of Bill and Bills, since that's what I'm playing around with. Bills is the plural of a singular term. What is that singular term? Bill, right? And so what we're essentially looking for is, we would call this the root word. If you strip out all of the grammatical rules that we have in English or in other in other languages, you strip out all those, present tense, past tense, possessive tense, all that, it boils back down to just this thing, right? This term. We call that the stem form. We're trying to just like, pruning a tree, we are trying to get rid of all of those things that we do and apply to tenses. So when I deal with that S, let me get rid of it. I don't need it, right? Because I want to focus on the key part of this, what the core concept behind this, the context. That same kind of thing. Now we get into weird parts. Replies. I'm going to ask that same question. What's the root word that I'm looking for? What's the base word? Reply, right? Well, now we're getting into an issue because it's not just dropping a character, right? Because, well, what do we do? How do we tackle this? What we can do is strip out the ES instead. This is known as stemmatization. Ugh, I know, that word ugly. Stemmatization essentially is saying, well, we're going to drop it. What are we left with? Well, yes, that's the root word. We're going to produce the stem of our pruning. Is it the same as reply? No, but it's getting us close enough. And specifically, as we sort of take a look, that does get us a few, again, it handles a lot of our cases decently. Does, do, or you do see a limitation here, right? Oh, let's look at that does. Oh, well, does, we're going to turn the stemmed version of that to do by dropping the S. But is that the root word? No, right? Again, think about what the root word is. The root word is do. So this does have limitations. Again, it's not that it's bad, it's an initial approach, right? This was our first foray in trying to do natural language processing when we're dealing with inflections on words and tenses of words. Another approach is to transform it into what we call the lemma. The lemma essentially has a mapping to these words. It says, well, I know that does has a direct mapping to a root word, do. I know replies has a direct mapping to reply. I know bills has a direct mapping to the root word. And so what we can do is instead transform these into, again, what we know as lemmatization, not stemmatization. Yes. What we do is we essentially make that conversion for us. So again, if we looked at something like sarcastic, now it's sarcast, we got rid of the ick part of it, right? But that really wasn't what we were, that wasn't the context. That was this weird, pruned version of it. So lemmatization, does maintain it, but it does kind of have its own limitations. You can see, again, it's not perfect. Do still, or does still transforms into do, but it does a better job. As you can see, again, that's where the terms come from. Better and good, right? Better and good. They both fall into the same, what the hell? Sorry, I apparently got logged out of my own Panopto. There, I'm back on it. So, sorry, chat, if you did a message, you did a message. No, so again, what we're looking at here is this idea, stemming will also sort of handle this problem for us, right? And will sort of maintain some of those, inflected words and tensed words into the same term. That way, it again solves some of our issues. So again, sometimes it works, sometimes it's beneficial, right? The word why, right? If we're dropping whys, right, it would turn us into that reply with an I. Dropping the Y and replacing it with an I does that same thing. Yes, right? Again, it's a transformation. We're trying to, again, get to that notion of what's that core context of the message. Yes, it's a hard problem, but this is where it stops being English and it starts becoming math. So, then what do? The next step is, now that I've converted the words into their root or stems, I then drop off those stop words. I get rid of them. Because again, if we're looking at the stop words, right, they're too frequent, they're too excessive, which is going to cause them to be insignificant when it comes to the difference between real text messages and spam, right? Again, look at the original blocks for these. Look at the original box for these. Now look at what happens when I remove out what we would call stop words. Oh, now I've reduced my problem. Think about it again. It's a math problem. These are variables, right? These are numerical values. I've just made the complexity of this math problem easier by trimming a lot of the excess that will impact the math model, but won't do much for the classification, right? Now I have a much smaller data set to work off of. So as a result, again, since those stop words are so frequent, it would actually bog down our system. By getting rid of them, we're now looking at just what's the important parts of the text. So let's arbitrarily look at the sentence, sorry, I'll call you later. Real or fake? Huh? Real, right? No scammer wants you to, again, literally, if you've ever watched a Kit Boga video on YouTube or on Twitch, literally they don't want you to hang up, right? Because the second you hang up, they've lost the mark. They've lost their target. So they don't want to call you later, right? They want to work through it now. But either way, let's convert it. And I'll, throw in this nice little link as well. Here's a library to do it. Here's how you can get started. Here's how you work through using it in Java, right? Just like with Apache Commons, Apache has OpenNLP. It'll do all of this stuff for you because, yes, it's hard. And rather than reinventing the wheel, we do have libraries that solve those problems for us. Yes? Yes. It was dropped. I didn't do these. OpenNLP did it. So researchers, and when we have the groups of people who have looked at it, I is essentially a stop word. It's not a good word to kind of base a conversation on because, again, think about it like it's not I'll, it's two separate words. I was dropped. Ill, which is will, essentially, was kept.
That makes sense. Just the fact that they dropped I but not you. But I guess I don't believe in you.
Again, yep. That's where I will reflect and say I don't know why. But again, that's, yes. So I apologize for not having the answer. If you dig deep, I can send you an email. I will redirect you to Dr. Munadar Singh. He's our NLP instructor here at NC State. He'll probably answer the same thing of just like I is a root word or I is a stop word. And then when you ask, well, why isn't you? He'll be like, because it isn't. Groups of people have sat down to agree which words are and are not too frequent or insignificant for mathematics, if that helps. Either way, I take it, I've extracted the will, and now what happens next? Okay, well, we have a small message, and I did that on purpose because 5 words is a little easier to wrap our brains around, right, than wall of text. And so now what happens? Well, we get to return to the land of probability. You're going to learn that that's a lot of everything in these next few lectures. So if you didn't like probability when we talked about it, you're going to have to deal with it. But yeah, literally we look at that and say, okay, well, I have 3 observed variables. I have 3 observed variables. Oh, goodness gracious me. That's words that I remember. I have, not mine. I have 3 observed variables, right? I'll just kind of cheat and do them like this. L, C, Y, L2. Oh, would you look at that? Suddenly, this is a probability math problem. I've condensed it down well enough that I can do that. And in fact, again, how do I decide whether or not it's spam or not spam? I calculate, well, given my observed variables, what's the probability that it's spam? What's the probability it's not spam? And then, whichever one of those probabilities is the bigger one, has the higher likelihood of, being the more probable, there's our label. Again, you can do this any different ways. This is the fun part of some of our classifiers. It is a little more open-ended. So yeah, do the probabilities of both of them. Whichever one was the bigger one, that's your answer. Or again, maybe that's not how you want to tackle this. You could have an estimator. You could have some threshold, like a spam blocker, right? Now, just what's the probability? If that probability is like a 95, then yes, it's just spam. Just because those are all words that are, are very important, common in spam detection. So put them in the spam folder on your email or flag them for a moderator to review. All of that stuff comes into play. Both of those will work. And so now, I danced with it. Oh my goodness. I peppered in the fact that this is just math at the end of the day. And you might remember conditional independence formula, right? Well, that becomes a little harder to do. That becomes a little harder to do with all of these calculations because, again, think about that. That's a very large corpus, right? It's not just SL1, CY, L2. It's also free. It's also Matrix 3. It's Star Wars 3. It's every word in essentially the data set. That's where the bag of words term came from. So this becomes a little difficult to work off of, right? Because, again, think about that from trying to calculate. You have to say whether or not this is in that probability, every value, right? You remember the 16 calculations you had to do for the Bayesian network lecture exercise? At least double that. Just at least double. My point being, instead, when we introduce now what we call the naive Bayes classifier, we use a different a different theorem. This time, instead of looking at it from that conditional theory, conditional independence equation, where we found the equivalent here, this time we're changing it up. We're essentially going to flip it around. We are going to say, well, what is the probability of just spam happening, right? What is the probability? Let me get my writing thing back. Spam. Which, again, that turns into spam. And again, that turns into spam. What is the probability that spam just happens in my data set? Again, just what's that overarching, how many labels do I have as spam? What percentage of the data set is spam? Then, notice the B. Well, again, I have my evidence. I have my observations. What's the probability that that just happens in spam alone? So we flipped it. Now it's not what's the likelihood of spam given my observed evidence. What's the likelihood this happens in spam is what I ask in the second sort of portion here. And then finally, what's the likelihood that my evidence just happens at all in the message? And so again, here's where we're going to throw in a little bit of stuff. We're going to assume that A and B are independent of each other. Then, if they are independent of each other, A and B should be, or A given B and B given A should technically be different because they're independent calculations. Therefore, they're not equal to each other. And so what happens? Well, again, let's start to take this, let's start to apply it out. What you see suddenly is this calculation. What's the probability of spam given my observations, given the variables, my texts, right? That pans out into this mathematical formula going on here, right? That does all that replacement for us. So to read it out loud, I color-coded it and everything to hopefully help, right? The red part, what's the probability those words appear in spam messages, in the spam section of my data set? What's the probability that spam is in the data set, just period? What's the probability that those sequences just exist at all in the data set? So how much is it in the spam data set? How much are those terms in the data set as a whole? Following? So how do I do that? Okay, well, now we got to take this one step further, because clearly that's an ugly math equation. And yes, and you'll be happy to hear you do not have to do this on your final. You're welcome. But I'm helping you understand naive Bayes classification. So we're going to open up with an assumption to naive Bayes. Naive Bayes assumes each term is independent of each other, aka each variable is going to be independent of each other. You notice that there's an asterisk there. So some of you, I'm not gonna give you the answer, but something about that should sound fishy. And I'm going to move on. I'll touch on it later. But okay, here's an assumption that we're applying to our text. Just think about that. Now, what am I going to do? I need to spit these out, and I need to kind of do the calculations for each one. So what happens is that math problem gets exploded. I'll take just the probability of, sorry, I'll call you later, given spam messages. Well, I'm going to find the equivalent to that. I'm going to look at what does that translate out to. Again, if we were playing and we saw this from the probability perspective of my from all of the probability and statistics that we've seen so far, right? What that translates into is, for each one of my variables, I'm essentially saying, what's the probability, sorry, given I know that message is spam? What's the probability sorry appears in spam? What's the probability will appear in spam? Times, what's the probability that call appears in spam? Times the probability of what you appears in spam. Times the probability of later appears in spam. Now, yes, I want you to think about just the math for a second. What kind of value are you going to get after you do all this multiplication? Between 0 and 1. But that's with all of them, right? So I want you to kind of stew on that a little more, Alex. They're all 0 and 1. And so what's going to sort of essentially become the end result of I'm only working off of 5 characters, but also remember that some messages may have 30 tokens. Mm-hmm. Well, just more to the point of what happens if they're all small. Just arbitrarily, 0.9, so let's just arbitrarily say that we have 30 terms that all have a high probability of appearing in spam messages, right? There's a 90% chance that this appears in a spam message. Over 30 terms. This is Python short text of doing 0.9 to the 30th power. Well, 30 terms, wouldn't you know? That's a very small number. Even with 90%, just everything's 90%, suddenly the probability of all these terms appearing together turns into a 5% chance. But you remember, like, hey, that's not, that becomes a slight problem, right? Just, those are very small numbers. Remember, fractions upon fractions. What happens if it gets lower? What if instead of me doing 90%, because I was being generous, 60%? Oh, look at that. That's an ugly number, right? Because it's got the E going on, right? 7 zeros before we get to a 2. That's hard math, right? Again, now we're at a limitation of the computer because decimal division, we're still dealing with floating point numbers. Very small numbers and very big numbers cannot be handled on the computer. Just We try. We build new libraries to do it. So that becomes a major issue. Now, here's where you're going to hate me again. I'm going to say, well, rather than doing super ugly, crazy math, again, that's just me saying those things. Instead, I'm going to show you the log property. Oh, the log property. Because instead of me doing that ugly multiplication the entire time, which is all I was doing, right? Let me change color here. That's all I was doing right here, right? I was doing the product, the running product of my probabilities. Well, what happens if I wrap that entire thing into a log, right? Just have an upper bound, lower bound where we do trail off as we add more and more to this. Oh, well, that gets an equivalence where it's now the log of the P1, P2, it's the log of all of our probabilities. And then that turns into just the summation of those logs. And so I'm going to take that same approach, but now I'm going to, use my running total. And then I'm going to go in. And I'm going to cheat and just have the formula also on the screen as I work, right? So now, in range, we've been working off of 30 of those. I need to there. As M. Now let's go into those for loops. Now, total is going to be added with specifically the log. The math.log of 0.6. Right? Because again, we hand wove what the probability is, and I'm just saying that every term here has a 60% chance of appearing. I'm going to do a summation on all of those logs. Yes. Yeah. It doesn't. This is where this one is log base 10. The decision tree was specifically log base 2. At the end of the day, like the base part doesn't matter because we can convert between them all like freely. So it doesn't really matter which base you're in. Yeah. But for our sake, this one just relies on base 10. I'm showing you base 10 version. Now, the big idea here, though, is notice what total turned into. That's a big number, or that's a normal number, right? Negative 15.32. You can do math on that without needing special libraries and functions and everything, handling super small and super large. That's a number you can deal with, right? Again, that's 30 terms with just an approximate 60% chance. That's a number you can work with. Oh, well, guess what? I can probably do that at the very bottom there as well, right? I could do the same thing going on there, and this is me just plugging that in. And so what you end up getting is now sort of that naive Bayes classification. What is the probability of these things happening, plus what's the probability of the log of spam? Again, if I'm working off of the log around the entire probability, I do also have to account for the spam. Again, I plug those numbers in. Ta-da! Congratulations, you now know how to do spam filters. You can build these into, you could build a mail server, you could build your own Gmail, and now when you accept mail, you can do this. Like, okay, it's not that hard, right? Yes, okay. You know the math behind it. You know at least the original math behind these things. So yeah, you're not maybe the king of the castle or the state of the art. Who cares? It works. It's covering like 60% of your use case, and that's a large portion. So you're already above halfway there just by implementing the math. So here's where we introduce now some of the pros and cons. Pro, doesn't need a lot of data, right? Because again, you're working off of probabilities of data. As long as it's, good data, it doesn't need to be big data. So I can work off of, 10,000 records, and if I have a very clear separation of what appears in spam and what does not, because again, I drop off frequent words, awesome. And that actually turns this into a very fast training problem. And this is a major issue, again, with a lot of our issues is how long does it take to train? Think about that like the brute force approach to adversarial search. If it took you 10 years to, figure it out, wasn't really a good model, it's not beneficial. So we do want something that can be much faster. Here's the problems though. Good classifier. It actually, again, it works very well. Most spam filters, again, I can't speak for all spam filters, most spam filters probably still utilize some form of a naive Bayes classifier, or at least as part of the whole filtering process. But it's not good at estimation. Again, that probability is not the same as estimating just valence levels of something. And we'll talk about that in a little bit. Works very well with discrete values. Text is a discrete value. What happens if I tried to turn this into, let me use a naive Bayes classifier for the iris data set? Not so good anymore. Not so good because, again, that's continuous values. What's the probability of a continuous value? Well, the probabilities of this appearing are going to be different than this, which are going to be different than this, right? Which are going to be different than this. Just being one more, right? Think about that from a probability perspective. That's a different number. If I'm trying to tokenize, that doesn't work out that well. And I threw out one earlier about an assumption about naive Bayes. Just to remind you, someone I have not heard of. If I got my regulars, I want someone who, maybe has been a little more quiet. Why would words being independent of each other be problematic? Say it loud a little more. Yes! Context is king when it comes to text. Remember, think about the word bill, right? Am I referring to a person or a thing? Well, I need to know the prior context of the message, the communication, all that stuff. There's so much context that I need. For naive Bayes to be independent, that's a limitation to the naive Bayes classifier. Again, works super well. So it's not that it's, again, we just look at the bag of terms and we can do classification. The issue is it's not realistic to now translating what we are doing into kind of a real world context, right? Words do have meaning. Words do kind of follow each other. There are trends of words. This may sound like I'm priming you up for when we talk about large language models, right? Words have context. Words have history. And I don't mean that in like the history of a word. I mean like a word came before I said history, right? So as a result, that's not how words actually work. That's not how English or any language works. So we're doing something, it does a good job, but it's not actually how we do things. It's a sort of a limitation now to approaches. You'll also see, just funny enough, this is why people are resistant to large language models. Because that same kind of, they're behaving like a human, but they're doing things that humans aren't, they aren't adding that little, that humans have, that little je ne sais quoi, right? They don't have that. But again, I said that there were cons to this. So let's arbitrarily look at some message off the internet that I just pulled randomly, from back when Reddit still had awards. But if you look at this, okay, we see a block of text. Is this a positive or negative review of the movie? Okay, and yeah, I think I bid. It is randomly selected. I grabbed one from like the movie subreddit, changed the username to clearly, what is it? Bolster my own ego. But clearly, again, that notion is like, hey, this text message, it's harder, naive Bayes and natural language processing. We do have sentiment analysis approaches, but the naive Bayes limitation here, and actually it's open research, is like, well, what's what is the emotion to this? What is the valence of positive or negative message? Because again, this one works, very nice grammar, and I think I may have tweaked it a little bit to be proper grammar. Is everything on the internet proper grammar? No. I've seen your discords. I keep on bringing it up mostly just because y'all don't know how to type, but again, none of us do, right? If I pulled up my family group texts, my equivalent of Discord, they ain't pretty either, and they're like filled with pictures of memes as well. But that's open research. Like again, naive Bayes is going to struggle with this. It's good at making a distinction. You're a positive or a negative. But how positive, how negative is open research, right? That's where we have limitations and where we still do natural language processing out, research, because we don't know which one is, how good, like, is this overwhelmingly positive or is it mildly positive? Right? Welcome to why game reviews essentially are fine, or most reviews. Welcome to any review, and essentially this is why you see bad movies are anything below a 6, and everything above the 6, it has to be 8 or 9 or 10, right? There's our weird buffer of like, this is garbage, this is perfect, or this is good, this is garbage, right? Because we don't have good ways of measuring, valence on these things. Another interesting kind of research area with natural language processing is obviously it's not just for spam detection. And this is, again, we're back to that, what are we doing in this world right now? We have millions of documents, scientific papers out there on the internet right now. My papers are out there. If you've done research and you've submitted it somewhere and it's been approved, your stuff may be out there, right? So all of this knowledge is out there for you to grab and read and, just process. But the problem is, what? Who here understands what this is saying? I'll give you a first part. TBI. What's TBI? Nope. Wrong. Just wrong. You were so confident, though, so I appreciate the confidence. But in this case, we are talking about traumatic brain injuries. So a traumatic brain injury, obviously, again, concussions, CTEs. So this is a paper specifically looking at CTEs, DAI. Again, look at these acronyms. And you thought it was tuberculosis, but that's actually a very important thing when we think about it from a medical perspective. Just how many terms are what we call named entities? It doesn't have to be an acronym, but it's, again, there we are. I can't even pronounce all of those that first word. Paroxysmal, right? That's a hard word. That's what we would call a named entity. It is unique specifically to the medical field, and so it's no different than when we think of naive Bayes or conditional probability. Those are named terms. They're not meant to be separated from each other. DAI is diffused axonal injury. It's when you're, in a TBI kind of a situation, your brain is sort of, your brain looks like this. DAI is when you have a traumatic brain injury and this happens. And you still are alive, but your neurons have just been sheared is the term they will use, where essentially, I guess, your brain just kind of twisted a little, and that you up. But again, how do I start to kind of process this? Again, we're trying to turn this into math, right? So I have to find context of like what a medical condition is, what are locations, just to make this a little easier for us. You understand what the ICU is. You understand what a hospital is. You understand what a classroom is, right? That's not the only places. So again, if you're I'm really kind of interesting you suddenly. Medical journals aren't the only things. We also have argumentation papers. Again, this is critiques on them. This is a section of, this is the literary section that is considered background context. But that same kind of concept can go in there. Oh, well, let me look at the argument. And this is Dr. Colin Lynch's lab here at NC State. They are doing this. So if you're super interested, reach out to Dr. Lynch. But again, that same concept. Let's look at a message to say, what's the main clause or the main claims of this message? Well, then how are you supporting that? Well, you have claims, and those claims have their own premises. And premises, again, this is all argumentation, but argumentation is where you start to see something like legal documents. Oh, wouldn't it be great if we could apply a mathematical formula or represent legal documents in a formal fashion? Right? What's even the formula for that look like? What makes a good court case? What makes a good argument? Yes, we have open research here at NC State trying to tackle that problem. Other things, this is more relevant if you're like, I want to just go work out in industry, right? You all enjoy the fact that you can auto-complete on your phones. You can just do the tab swipe or whatever, and Google Gmail auto-completes your messages. Funny enough, so that was one of my colleagues when I was here for my grad program, Linting Zhu. She currently works at Google. Her research was literally tokenization, taking our terms, and instead of just looking at it as a term, right, we add context. Now, I believe blah can be transformed into, if that's the start of a sentence, and this is what I would see, rather than having 3 terms, 3 tokens for my math equation, shrink it down to 1. Just shrink it down. Saves a lot of math. But to kind of finish things up, this is where we're going to have a little fun. All right, let's try and figure out, again, we've tried to tackle spam. How about hate speech? So fun, we're going to see who's got some really dark, skeletons in their closet. What does 88 also mean? Alex, I already know that. You don't want to admit it? Okay. Keeping that closet nice and clean. Anyone have a nice little fun idea about what that one is? About what 88 means? Oh, you know it. What's HH stand for? I'll say it because I get it. So 8 references the 8th character in the alphabet, which is H. So 88 refers to HH, which refers to Heil Hitler, which is, again, a neo-Nazi kind of. So the term, if you start seeing 88s, yes, if you were born in 88, yes, this makes things a lot awkward. The nose emoji. Who wants to throw themselves on this sword? Nope. This one is starting to refer to the current conflict in the Middle East with Gaza and Palestine, because the stereotype that is the derogatory stereotype that is used for Jewish people is one of their characteristics is the nose. And so throwing the nose emoji. Again, if you have the context of this is something about Palestine or Gaza and things. If you see this all of a sudden, guess what? You're now dealing with hate speech that's thrown in there. Jogger, just to speed through these because I don't have time. Jogger refers to Ahmed Abri, who was shot and killed as he was running away because he was jogging. YT, say that aloud a little bit faster. Whitey. So all these, how do you... This is hard, right? Again, I'm over my, but this is all hard. And so I encourage you to read the Yishan just Twitter feed or post on trying to understand how all of this works because again, these terms evolve, right? Jogger was not a negative term until was not a negative term 10 years ago. Gay was not a sexualized term 100 years ago. Right? These terms evolve and change. How do you combat that if you are dealing with online content suddenly, right? You can't. It's hard. So what do? We look at patterns to try and see this. And then I open up the door to some more interesting questions. What do you do when you detect it? Should you police it? Should you automatically, what should you do to moderate it? Should you automatically moderate something, remove it, That's the open discussion. That's where a lot of our congressional hearings on the difference between a publisher and a platform are starting to come into play. Which one are you? Because if you're a publisher, you're allowed to censor. If you're a platform, you're not. So, last little bit, there's a link for an Open NLP. But hopefully I had a little fun with you while I taught you a little math. So I'll see y'all next week when we finally tackle neural networks. That's right, you can't leave for Thanksgiving. You got to be here for neural networks.